Video, let us try to analyze the static power consumption of a resistive load inverter. Of an RL inverter, let us try to find out the static power consumption. So this is the RL and this is the NMOS transistor and this is the input, this is the output. See, there are only two possibilities. When the input is 1, or let us take the input as 1, this is RL. When you make the input as 1, there is a path between the VDD and the ground. Okay, there is a path between the VDD and the ground, right? And as you can see here, the current there is a current flow between VDD and the ground, because you are making the input as 1, which will short this NMOS transistor. The NMOS transistor can be replaced by an equivalent short circuit, right? Because the transistor is on, it will make a short circuit here. So here there is a current flow from the VDD to the ground, because both resistor as well as the NMOS transistor forms a path from VDD to the ground. So since there is a path, there is a current flow, and we can take this as VDD minus VOL divided by, or I could say VDD minus ground, right? VDD minus ground divided by RL. RL is the resistance in the path. So VDD minus ground divided by RL. So this is the ground is 0. Not a problem, ground is 0. So VDD by RL is the current flow here. VDD by RL is the current flow when you make the input as 1. Similarly, for the same resistive load inverter, when you make the input as 0 means, there is no direct path between the VDD and the ground. So when you make the input as 0 means there is no static power consumption, I could say. So only when the input is 1, there is a static power consumption, which can be given by VDD divided by RL. That is the current. You have to multiply again with VDD, because you know that static power is what? VDD into RL. I mean VDD into ID, right? The voltage into current. Voltage into current. Voltage is VDD. ID is nothing but VDD by RL. So this is the static power consumption. This is the static power consumption when you are having V in as 1, static power consumption of a resistive load inverter. Thanks a lot.